Hi everybody, my name is Roberto. I will present my portfolio about artificial intelligence and digital games. In this work, it was implemented an intelligent agent to play 9 modes. There are 3 phases in the game. The first is the placement of 9 pieces. The second is the movement phase, in which each part moves to adjacent positions. The third is when one player has only 3 pieces. At this stage, this player moves the pieces to any position that is empty in the board. In the game, when a player aligns 3 pieces of the same color, he can remove a piece from the opponent. The game ends with a winner when one of the players present less than 3 pieces or cannot move the piece. If players repeat the last 2 plays in succession, the game ends in a draw. In the Tron game, an intelligent agent was implemented in C++. There are different bots and maps to compete against this agent. So, in the implementation of the intelligent agent, it was used a minimax algorithm with Breeding alpha beta in order to build partially a space of states. Furthermore, a listed graph libraries and Dijkstra algorithm were done to this work. To determine how many units are required to win a particular group of units, allowing for a better army composition in the Starcraft 1 game, first a map with different game races has been created, present in parts for unit creation, combat region, and regions for units to be eliminated. Then an agent was implemented in the W API using C++. This agent respects a state machine. First the units are created, then the units are sent to the combat zone. The third step is to wait for all units to reach in the region of conflict. In the next step, the units search for the conflict. Then they wait for the end of the battle and await the winner. If any unit remains, it is sent to the abyss. Then note down the number of units needed to beat the opponent, or increase the number of units and try again. At this moment, the bot sends one soldier to the combat region, and the human player sends 2 different units to the combat region. The soldier is defeated, and then the robot increases the number of soldiers and sends now 2 soldiers to the combat region to see if the 2 soldiers are capable to defeat the human units. The same process is repeated for the different units and until the all proportion of units are determined. Then the equivalence table between Terran and Terran, Terran and Zerg, and Terran and Protoss are gotten. The first game implemented was Super Top-Down Racing. The human player controls a McLaren, and this is a race game with camera from top to down. The player who completes the number of laps of the race faster wins. There are 2 phases, an initial phase with a simpler map and a final phase with a more complicated track to go through. What was implemented in this game? The player's vehicle can accelerate, brake, and reverse. Vehicles collide against walls. Vehicles do not collide with each other. 7 opponents were implemented. Each one presents a path and a speed in each phase. Countdown timers for the start of the race were built. two invisible lines on each map, where the player must pass through these lines to complete the lap. Each vehicle at the finish line can know what is its position. The game sprites are acquired according to the game credits. The other game that I created was named by Shadow of the Monsters. This game was created in Unity 3D using C# language. This is a partial action game in a 3D environment. The 3D models of characters in environment were obtained by internet, such as specified.